Look, it is 4 p.m. on a Friday. You are about to close your laptop. You want to have a quiet weekend, then the alert hits your phone. A customer tried to buy a subscription. The payment service says the money was taken. Your database shows the payment record, but the user's account is still basic. The table of the user permissions is empty. You look at the logs, you see a constraint violation exception. It happens in a completely different part of the code. A clean code listener caused it. The payment stayed. The permission vanished. You have a partial data. Congratulations, you just learned that your service is actually transactional. You are now a manual data entry worker. You will spend the next 4 hours running SQL scripts to fix the mess. Your diner is getting cold. We all have been there. We trusted the transactional annotation. We thought it was a magic shield, but the reality is different. Most developers use it like a lucky charm. You put it on a method and hope it works. Today, we stop hoping. We are going to understand why your Spring Data transactional fails. My name is Sergio, and I spend too much time thinking about transactional integrity. I think about why we build systems that fails in predictable ways. If you are tired of debugging impossible database states, hit subscribe. Give this a thumbs up if it helps you. Let's be honest, your weekend depends on this. Here is the thing. Most developers think transactional is magic, but put it in a class. You think your data is safe? You're wrong. Spring Transaction Management is not a database feature. It's a proxy-based abstraction. Most bugs in senior level code are not Spring bugs. They are a lack of understanding of the Java AOP. We are told that Spring makes things easier, but this is not true. Spring makes things convenient, but it also makes it to do the wrong thing. You will not even see a compiler error. You have traded deep knowledge for simple annotation. We will look at the scope, the proxy trap, and why no transaction is a dangerous state for the application. Let's start with a common senior mistake. I see this in every PR and review. It's the self-invocation problem. You have a service. Method A is public. It has no transaction. Method A calls method B. Method B has the transactional annotation. You think a transaction starts when method A calls method B. It does not. In this code, when you call process order, the annotation on save order is ignored. Why? Spring wraps your bin in a proxy. When an outside class calls your bin, it calls the proxy. The proxy starts the transaction, then it calls the real method. But when a method calls another method in the same class, it uses this. It does not use the proxy. It goes directly to the real method. We are running in auto-commit mode. Every SQL statement is its own transaction. If payment service charge fails, the order repository save is already committed. You created a zombie order. It exists in the database, but it was never paid for. The reality check. If you want the transaction to work, method A must be transactional, or you must move method B to a different bin. Stop trying to hide transactions in internal methods. Next, we need to talk about checked exceptions. Spring has a default behavior. It is important to remember. A transaction only rolls back on unchecked exceptions. This means runtime exceptions, an error. If your code throws a checked exception, Spring will commit the transaction anyway. In this example, the order status changes to processing. The exception is thrown, but the database saves the change anyway. The transaction manager sees a checked exception. It assumes you handled the error, so it commits. The fix: you must be explicit. If you use checked exception, you need this. But let's be honest for a second. Why are you still using checked exception for business logic? It creates more work. It breaks the abstraction that are meant to help you. Let's look at the propagation. Especially propagation requires new. Developers use this when they want to save a log even if the main task fails. They think it is a safe way to isolate work. Here's what really happens. Spring pauses the first transaction. It opens a second database connection. It starts a new transaction. It commits, then it goes back to the first transaction. The hidden cost: you are using 2 database connections for 1 request. If your traffic goes up, you will run out of connections. Your app will crash. There is also the deadlock risk. If transaction A logs a row and transaction B tries to update the same row, you have a problem. Both transactions will wait forever. Your application thread will hang until it times out. The no transaction scenario: what if you do not use the transactional annotation? Spring Data simple JPA repository uses transactional on its own. Every call to save, it's a tiny transaction. If you call save 10 times in a loop without a transaction, it opens the connection, starts the transaction, inserts the data, commit, close the connection, and repeat 10 times. This is a performance disaster. You are paying for connection management 10 times instead of once. Why do we keep making these mistakes? It's often the rhythm-driven development. We want our clean architecture to look good. We use layers, DTOs, and listeners. We spend so much time on the patterns that we forget the database. We treat the database like a dump bucket. We think we can fix everything in Java code, but the database is the only thing that lasts. Your Java code will be deleted in a few years, but that corrupted data, they will stay in the system for a decade. We also have the cognitive overload. You have to think about Kubernetes, Kafka, and React. You do not have the energy to remember how transactional aspect support works. So you just add the annotation and hope. Hope is not a strategy. I know what you are writing in the comments right now. But Sergio, I use microservices. We use sagas and outbox patterns. We do not need ACID transaction. If you cannot manage a transaction in one service, you cannot manage it across 5 services. Distributed transactions are much harder. Eventual consistency is not an excuse for bad local code. But Sergio, I put transactional on the interface. It looks cleaner. No, it does not. It makes the code harder to find. It relies on the implementation finding the proxy. Keep the annotation in the implementation. Be direct. What should you do on Monday morning? Audit your service layer. Look at the transactional methods called from the same class. If you find them, refactor the code. Check your exceptions. Look for checked exceptions in your transactions. Make sure you use rollback for or change them to runtime exception. Use read-only. For your get methods, use transactional read-only. This tells Hibernate to skip dirty checking. It saves CPU and memory. Log your transactions. In your local environment, turn on the trace login. See when the transactions start and end. This log will show you the truth. It will show you if your transactions are actually running. Transactions are not a set it and forget it feature. They are the base of your data integrity. If you treat them like magic, they will fail you. Fix your code, enjoy your weekend, do not let PagerDuty wake you up. If this helped you, share it with your team. Save another developer from a bad Friday night. And see you in the next video. Bye!